Have you ever looked up at the night sky and just wondered? Have you seen that endless blanket of black, sprinkled with tiny, shimmering diamonds of light, and felt a pull, a question bubbling up from deep inside? What is all that stuff out there? How far does it go? Are we alone in this vast, silent ocean of stars? These aren't new questions. For as long as we've been human, we have tilted our heads back, stared into the cosmic darkness, and let our imaginations soar. The universe is the ultimate mystery story, and every star is a clue, every planet a new chapter. Think of it as everything, absolutely everything. Every grain of sand, every drop of water, every person on Earth, every single star you can see, and all the ones you can't. It's a place of unimaginable size. Our galaxy is just one of billions, maybe even trillions, scattered across space like islands in an infinite sea. For thousands of years, we looked at the moon as a beautiful, mysterious light in our night sky. It was a god. It was a guide. It was a storyteller. But then, something incredible happened. We decided to go there. When the Apollo astronauts took those first steps on the lunar surface, they kicked up more than just dust. They kicked up the dreams and aspirations of an entire world, proving that what seems impossible today might just be tomorrow's great achievement. It showed us what we could do when we worked together on a big, bold idea. It was a triumph of science, engineering, and pure human courage. From the moon, they looked back and saw our Earth, a small, fragile, blue and white marble hanging in the blackness of space. That single image changed everything. The moon became our first stepping stone, outposts where astronauts can live and work, preparing us for the longer, more challenging journey to Mars and beyond. The moon landing wasn't an end. It was the spectacular beginning of our interstellar story. Imagine you're in a spaceship that can travel faster than any we've built before. Your first stop, get up close and personal with a star. From Earth, stars look like tiny pinpricks. But as you get closer, you realize a star is a raging, chaotic inferno. It's a gigantic ball of incandescent gas, a nuclear furnace constantly turning hydrogen into helium. You'd see massive loops of plasma, larger than a dozen Earths, arcing from its surface. You'd witness solar flares, violent explosions of energy, blasting radiation into space. Now pull back. That star joins a cluster, which becomes a tiny part of a breathtaking, swirling structure, a galaxy. Our home, the Milky Way, is a spiral galaxy, a magnificent cosmic pinwheel with sweeping arms of billions upon billions of stars. It's a city of stars, mixed with glowing gas and dark dust lanes, a dynamic, active place where stars are born and die. You'd fly through nebulae, stellar nurseries painted in brilliant shades of pink, blue, and orange, like sailing through a cosmic watercolor. For decades, Mars has been our neighbor of fascination. It's close enough to see with a telescope. Its reddish glow has sparked tales of Martians. No little green men, but our Mars story is a real epic. We've sent a fleet of robotic explorers, orbiters, landers, and rovers. Spirit, Opportunity, Curiosity, Perseverance, each a character in our Mars story. They're our eyes and wheels on another world. They've drilled into rocks, zapped them with lasers, and listened for the Martian wind. The big discovery: Mars was once warmer and wetter. We see dried riverbeds, lake beds, and minerals that form only with water. Perseverance carried Ingenuity, the first powered flight on another planet, proving flight is possible in Mars' thin air. Next, bring Martian rocks back to Earth. After that, send humans to walk on Mars and look up at that red sky. These missions are incredibly difficult, and their successes have been spectacular. The solar system isn't just the sun and the planets. It's filled with countless smaller objects, leftovers from when planets formed. Comets. Think of them as cosmic snowballs. Ice, rock, frozen gases like methane and ammonia. They live far beyond Neptune in deep freeze, dark, and hard to see. Time capsules preserving the solar system's original ingredients. A gravitational nudge can send a comet inward. As it nears the sun, the ice vaporizes, releasing gas and dust that form a glowing coma. The solar wind then pushes material away, creating two tails, a curved dust tail and a straight blue ion tail. Asteroids are the rocky cousins of comets, rock and metal, also leftovers from formation. Most live in a wide band between Mars and Jupiter, the asteroid belt, ranging from pebbles to dwarf planets like Ceres. By studying them, we learn about Earth's origins. They may have delivered water and organic ingredients long ago. They are messengers from the past, carrying clues about the birth of our world. Of all the strange things in the universe, maybe nothing captures the imagination like a black hole. We even have the first ever real image of a black hole's shadow. So what is a black hole? Think of it as gravity turned up to an incredible degree. It can happen when a massive star runs out of fuel and its core collapses, squeezing enormous mass into an unbelievably tiny space. Imagine crushing a mountain down to the size of a sugar cube. On a cosmic scale, this creates a boundary, the event horizon, a point of no return. Nothing, not even light, escapes. But we detect them by their effects. Glowing accretion disks of hot gas that shine brightly in X-rays as matter spirals in. We see stars whipping around invisible points, gas pulled from companions, and bright X-ray signatures, the telltale signs of a black hole feeding. Black holes are not cosmic vacuum cleaners. You must get very close to be in danger. If our sun were replaced by a black hole of equal mass, Earth would still orbit. We wouldn't simply get sucked in. But what happens past the event horizon? Does matter crush into a singularity or lead elsewhere? We don't know. One of the most mind-boggling discoveries is that the universe is getting bigger. It's not expanding into anything. Space itself is stretching. A good way to picture it is a loaf of raisin bread. As the dough rises, every raisin moves away from the others. When we look at distant galaxies, almost all are moving away. The farther they are, the faster they recede. This expansion has been happening since the Big Bang, about 13.8 billion years ago, when the universe began in a hot, dense state. Will expansion stop? Scientists once thought gravity might pull everything back in a big crunch, or that expansion would slow. Instead, we found the expansion is speeding up. Something called dark energy is pushing galaxies apart. Dark energy and dark matter together make up about 95% of the universe, leaving only 5% for stars, planets, and us. We are living in a universe propelled by forces we are only beginning to understand. Out there are mysteries and perhaps objects we barely imagine. The future is an open question, waiting for the next generation of explorers, thinkers, and dreamers. People like you. The cosmos is calling. What will we discover next?